Hello, everybody. Good morning, good afternoon, good evening. Welcome to our broadcast. Depending on whatever time zone you're joining us from, we're glad to have you with us. I'm Kenneth Wong. I'm senior editor for DE24, and I'm usually the host of this webcast series. Now, today's episode, the episode that you're joining, is the role of human designers in the age of generative design. And this is sponsored by Sonara. Just want to make sure that you're tuning into the right episode. Okay. Now, before we begin, here are a few tips so that you can get the best possible experience from this webcast. If you have questions about today's topic, or if you have questions for the panelists, you're welcome to submit them into the Q&A box at any time. We will take as many of your questions as we can, as time permits, during the live audience discussion time. And for the ones that we cannot get to, I promise you we'll work with our presenters to make sure that you get a written response. You can also download a PDF copy of today's slides and check out the resources also to the resource list, and that's usually on the left side of your slide window. This is going to be recorded, so in case you feel like this is going to be worthwhile and beneficial to some of your co-workers, please feel free to refer to them and give them the same link, and they can watch the recorded link. Or if you happen to be having a busy schedule and you need to drop off halfway, come back and watch the recorded session. Okay. If you experience any problems, technical problems, that is, visit our webcast help guide icon, and that's usually the help ? Icon, and that's at the bottom of the console. If the slides are not advancing, press F5 or refresh your browser. Usually that solves a lot of the problem. Okay, now today's topic is about the idea that we are having a lot of integrated AI functions and even natural language supports in our design and simulation tools. So it changes the way we use what used to be simple parametric design tools and what used to be simple finite element analysis or computer fluid dynamics analysis tools. How should we use them, and what happens to the role of the human designers who usually make critical decisions? We'll discuss that. And first, we're going to have opening remarks from our speakers. I'm going to start with opening remarks from Andrew from Sonara. Andrew, welcome. Your self-introduction and opening remarks, please. And the slides are in your control now.
Thanks so much, Kenneth. Yeah, my name is Andrew Sutterly. I'm the product management lead and software partnership lead for Sonara. At Sonara, we believe we're going to be part of the reason that engineer changes. As Kenneth was saying, generative AI, large language models, all of these things are approaching other industries. And now we see these coming to the engineering space. Sonara is a company. We were founded in 2018. We're based in the northern German city of Bremen, where we have worked for the past years to create a process automation platform for engineers. And now we're bringing that with the powers of generative AI to the future. Maybe just for a bit of terminology and language, there's a lot of different terms going out in the market today. And one of those important ones that we find is AI agents. And kind of a question that comes up often is, what is an agent? What is an AI agent? Well, we think of it as something that has the ability to communicate and reason through the use of large language models from companies like OpenAI, Anthropic, and others that are producing these tools that many of us are already approaching in our day-to-day lives. But it also allows these agents to use tools and workflows to interface with other software, other capabilities. We've seen a lot recently about MCP and a lot of interesting opportunities there. I've seen MCP integrations for tools like Grasshopper and Rhino to allow agents or users of OpenAI models to interface with their engineering products. But really the important thing is agents allow us to approach non-deterministic problems that generally humans are going to be working in. Now, when we think about agents, the next step is multi-agent systems. So when we start to combine these agents that maybe are working with CAD data, or they're interfacing with FEA tools that we're familiar with, or working with costing, when we start to combine these together, just like an engineering organization that you already have, you start to really enable these generative AI systems to produce results that go far beyond just a chatbot inside a product to give me the latest documentation that can start to actually tackle complex engineering challenges. And so the reason we think agents are the future, especially in engineering, is engineering is hindered a lot of times by the need for meetings. How often do we have the challenge of finding the right time to set up and coordinate between the design department, the engineering department, the management team? And an agentic system allows you to eliminate some of these communication gaps and allows the systems to work autonomously with one another without that need for physical meeting. And so I want to show a simple example here of a multi-agent system that we've put together for the RFQ process. And we can show you how that system can really speed up the ability to get through that process as well as adapt to changes. So I'm going to play a short video here now. And now we can see an example of this system working. So just like any organization, we have a manager that's going to be coordinating with another individual. So we have a commodity analyst that's going to interface with different tools, whether it's SAP, Excel, to start to understand what are the types of materials that are necessary. We can also have a CAD analyst that's going to start to design the components inside our assembly, purchasing analysis as well. So we're going to go off and have another agent working on all of these things simultaneously, coordinated by this single manager to start to try to find the best way to manufacture, design a component. And of course, at the end of the day, what engineering report doesn't end with generating a Word or PowerPoint document that gets sent off to another team. So this is an example of the type of system we've been working with a number of our customers to put together to solve some of the engineering challenges that their teams and organizations face today. And so the other question that might come up, when are multi-agent systems suitable? And there's kind of a spectrum, and I'm sure we're going to talk a bit more about the different ways that generative AI fits into design and engineering. It can be through multi-agent systems really excel in areas where there's a high need for autonomy and human-like task fuzziness. But we see also approaches where agents are used for single-purpose applications, or just bring AI to traditional rule-based workflow automation. And of course, workflows are kind of the foundation of what you're going to need to build agentic AI systems. Those workflows can span from simple reporting that we talked about, this generating of PowerPoint reports, all the way up through full system and full vehicle design. The basis of these multi-agent systems are the workflows that engineers create. So we're not replacing engineers, we're taking advantage of that, of their knowledge and their skills within these multi-agent systems. And finally, we need to connect to tools that engineers are using today. So whether it's Siemens NX or Altera HyperWorks or EOS Print or Facton for costing, we need to bring all of the engineering tools and platforms connected into these agentic or AI systems to allow them to work just the way that engineers would work today. And with that, I'll pass it back to Kenneth.
Very good. Thank you very much, Andrew. Look forward to hearing more about these multi-agent and different instances where they become useful. So now let's move on to the next speaker. Our next speaker is John Petty from JPR, an analyst firm that I know very well. John, you're up and the slides are in your control, sir. Your opening remarks for 5 minutes, please.
My microphone's on as well. Well, yes. Hello, everybody. Thanks for coming to this webinar. We all have busy schedules, so I appreciate you taking the time. Just give you a few factoids as to what we see going on. The AI revolution, and I don't think there's a better name for it than that, is similar to previous revolutions that we've had that we now take for granted. The internet being the most recent one. How could we ever live without that? Electricity before that, if you want, steam before that. And we go through these industrial revolutions over time. And as a result, we have much better lives and much more power. But there's also change and turmoil in doing that. And some people get displaced in the process. But the good news is, for it to be a really revolution, there has to be a payoff. And what we're seeing already in the early days of AI is that companies are reporting 7 to 10% annual throughput in this decade already. Our personal experience here at JPR is we're seeing something like 20 to 30% from our use of AI as an assistant. So the program is moving forward, and it's moving forward at just about every company in the world. And that may surprise a few of you. You may think that, this AI stuff is new and experimental. It's in real practice right now. So what does it do for us? Well, we have the opportunity to enhance how we work. And that's another double-edged sword, because some of the things we do are repetitive and boring and mundane. And those jobs will be shuffled off to the AI. The AI will do it, and probably do it better than you did, certainly faster. And then you're left with the question, well, what do I do? And the answer to that question is, you better find a way to make yourself valuable. Because if all your value to the company, the organization you're involved with, was to do routine, mundane tasks, then you are nothing more than a robot. And so, as my opening comment is, if you don't want a robot to replace your job, don't be a robot. So that's the big picture as I see it. Few comments about us, I guess. We're a research firm, been doing this for about 40 years now. We track mostly computer graphics, but computer graphics, because of the advent of AI and its use of GPUs, has led us into that space as well. So they're inseparable now, computer graphics and AI. Every movie and TV show that you have seen and will see will be AI generated, running on GPU. So there is no real gap there. So that's my opening comments. Kenna?
Very good. Thank you very much, John. We'll talk more about some of the things you've already brought up. So now let's go ahead and move into the discussion phase. So let's bring back Andrew online as well. Andrew, in fact, I'm going to start with you. There's a fear, of course, is that when generative AI's ability to churn out CAD models on specs or process simulation jobs based on your input gets better and better, the formerly CAD experts and FEA experts might be out of a job. Is that a well-founded fear?
I think John said it really well earlier. If what you're doing today is very robotic, yes, your tasks are likely to be replaced with other tasks. But what we see is that as individuals embrace these different evolutions of technology, whether it was, in the CAD space, let's think of traditional drafting to computer-aided drafting, from 2D drafting with tools like AutoCAD to 3D parametric design. These evolutions of technology have created demand for more and more designers, for more and more engineers. And so I think the tasks that we do as engineers, as designers, will change over time with the help of AI. But hopefully it enables us to start to do more of the tasks that we actually enjoy doing, more of the tasks that got us into these fields in the first place, right? I think a great example for me, when I think about non-value-added tasks that hopefully will be replaced to some extent by AI, report generation for simulation engineers. I've heard it range from 25 to 50% of an engineer's time is spent writing reports. And I think we can all agree, for most of us that went to engineering school, writing was not our strong suit. And these reports that get generated, oftentimes they sit in a filing cabinet somewhere. No one actually ends up reading them. So if we can use AI to eliminate some of those tasks and let you focus on the things that you actually enjoy about your job, I think overall we'll have a better working environment for designers and engineers.
I think those are very good points. And now that you mentioned that you don't like writing, I wonder if some of the PR pitches that I've been receiving every morning are AI generated. I have the feeling that some of them might be.
Certainly are.
So, John, I'm going to turn to you. Earlier, you started talking about how don't be a robot. So maybe you can give us some more insight. What does that mean? Does that mean we should become better at evaluating what the AI is proposing instead of doing what the AI can do?
Yeah, when people comment about AI, and it's interesting how our society works. But when you're afraid of something, you start to criticize it, and as a way of diminishing its power. And so people are criticizing AI and telling us what AI can't do. And it amuses me because that one of the first things they say is that, well, AI can't be creative. Well, flip that back and say, well, if AI can't be creative, can you be creative? And if the answer is yes, there's your job security. But if you can't be creative, then you're on an even playing field with the AI. AI is going to win. AI doesn't take vacations, doesn't take coffee breaks, doesn't get paid by the hour, et cetera, right? So you just can't win that battle unless you have something the AI doesn't. The second thing is, if you learn to exploit AI, and a little bit this kind of feeds into what Andrew was saying, is that it now accelerates your time to conclusion. Excuse me. And that gets back to a concept that we've been talking about for years and years in the computer graphics industry, was from concept to creation. And the mundane steps in between the time you have an idea and just the time maybe you can get it on paper to describe that idea, just that little bit of delay line causes you to lose the idea. So any obstacle you can take out of concept to realization is going to get you to the next concept. And then you get into stream of consciousness thinking. And that's where creativity takes place. And so if you can get into that mode because you're being assisted by the AI who's doing the mundane work, then your contribution to your company and to the world is really great.
Very good point. Andrew, I'm going to bring you back into the discussion here. I think you like the movie Iron Man because we talked about it before. And so people might have the idea that AI agents are going to look like Jarvis from that movie with a very attractive voice, and you can talk to it naturally. To some extent, that seems to be coming true. But can you help us set realistic expectation in terms of the kind of AI functions that'll appear in CAD and FEA programs? What's a realistic picture that we should paint about what we can expect it to do and not be able to do?
Sure. Yeah, I mean, we talked about it. I love the analogy of Jarvis. It's something that we strive to create at Scenario. We're inspired by this concept. But when we start to get into the practicalities of how agentic systems or AI systems are coming to engineering, I think from today to tomorrow, I don't believe we'll see Jarvis materialize in front of every engineer's desk. But certainly at some point in time, we're likely to get there. And what we'll see in the near term is, the same steps to get there are the steps that most companies are already trying to start to go through today. It starts with digitizing your work, digitizing your processes, right? How many processes are captured only in your head somewhere, or maybe written in a document that's stored who knows where? Once we start to digitize processes, then we can start to bring in agents to perform individual processes, and then bring in multi-agent systems that connect together all of these agents. So it's about starting with small use cases. I showed you the example for an RFQ process. I'm also working on another example I'll show next week at another event where we're using LS-DYNA, we're using Digimat, we're using MoFlow, and a variety of simulation and design tools combined together to automate the design and analysis process for injection molded parts. So it's going to start small and build over time. But I think in the next, let's say, 5 years, we're going to be really astonished at how far we've come and how far we've progressed with bringing these agentic systems into the engineering space. I'm much more optimistic about that transformation than the cloud transformation I've been hearing about in engineering for a long time. I think agentic and AI is really going to be the thing that sets off the next engineering revolution, like parametric CAD in computer design did in the past.
All right, John, you usually look at in your studies and research a lot of the mainstream CAD and FEA programs. And I think obviously we are now seeing the introduction of natural language input. not so much voice, but text support seems to be becoming a regular feature in many of the mainstream kit. How should we use them? Are they implemented in the right way? And are there any relevant reports or studies that you can point to?
Can't think of any immediately. I can't think of any reports, but the one thing that's going to happen as we communicate with LLMs and agentic LLMs is we're going to have to learn how to be more specific and succinct in the things we ask for. And so if I want, and I've done this, by the way, for a book I just finished, I asked, I think it was ChatGPT, I can't remember which one I asked, but anyway, I said, draw a floor plan of a house, 2 bedrooms, kitchen, 1 bathroom, not square. And it took less than a minute, and I had a floor plan. So then I said, and I want dimensions. The longest side is 20 feet. Bam, it did it. I couldn't possibly have done it that fast. I just couldn't. Not that I'm some superstar draftsman, but I mean, I have done drafting, and it would just take time for me to do that. So, and it was a pretty, common, mundane thing. Now, where I get involved is I look at it and I say, this is a really boring floor plan. Let's put a bay window in, right? Let's punch out one side of the wall and put an office there. Let's do this and let's do that. The AI is not going to do that. The AI might be able to do it under instruction if you can write the instructions carefully enough that it can find the hooks necessary to do it. But typically, you're going to do that. So that's where you take over. So the AI gives you the foundation, and then you turn it into a house.
That's a very good idea. Yes, that's what you're talking about, where you bring in the creative process and AI does the repetitive, mundane, parametric drafting things.
Get the dirty work out of the way.
Yes, yeah. Andrew, let's talk about reduced order models. Many of our audience are actually now starting to get familiar with the idea that you can bypass a full physics run in simulation and just use a reduced order model. But you seems to be hinting that you can also do a similar thing with processes, simulation processes. Can you expand on that? What do you mean?
Yeah, so I think reduced order models, as you said, are a concept that has started to grow kind of a familiarity within the engineering community and a comfortableness with working with them. And really, these are just ways of speeding up those simulation processes with a little bit of uncertainty kind of thrown in there. And with engineering processes, we see the same need to bring these to a level that you can automate them and have them run faster, in a sense, right? And so the challenge traditionally has been with automating engineering processes. They end up being very, very brittle in the way that you connect them together. Traditional pedo tools, you can't apply them to different problems generally. And this is where we see AI really bringing an advantage, or agentic systems, because now you can start to have flexible interfaces between bits of workflow automation. And once you start to bring in reduced order models to different aspects of that as well, you can have your agentic system that focuses on simulation sped up with reduced order modeling techniques as well. So there's a nice synergy here of bringing that technology into an agentic system to allow that agent system to work even faster than it was before. And I think the other aspect that plays well with agentic systems tying into existing approaches of AI in the engineering space is once you bring in these audit trails, a lot of companies that have historic amounts of data, if you think about an automotive OEM, the number of crash simulations and fluid flow simulations they run is incredible. And we can start using agentic systems also to start taking advantage of all of that data to make more informed decisions as well.
Very good. Okay, let me go back to John. John, you have looked at the way AI agents and natural language are implemented in many of the mainstream CAD and FEA programs. Do you have any praises or criticism, whatever there may be, or just simple observations? Are they doing this correctly? Are they practical? Is it in a useful manner?
Yeah, I have mostly praise, and I'll tell you why. Is when I think about who's doing AI, well, Adobe is there. You might not think of Adobe as being in an engineering situation, but a lot of the stuff is very engineering oriented. Autodesk, of course, Siemens, Dassault, et cetera. Graf, what's his name in German? I can't think of the name right now. All these companies have behind them, and this is not an exaggeration, hundreds, literally hundreds of super smart, talented people. And the collected wisdom and experience of those hundreds of people is being brought to and ingested in the AI UI that the companies are providing. So my personal experience is these things are extremely well thought out. Now, everything can be improved. We know that. Everything iterates, you get better and better and better. But right out of the box today, what you can do is just nothing short of amazing. And so, like I said, I have high praise for them because they have really thought these things out. And I mentioned to you earlier in a private conversation, they have to. Their company's business is on the line. If they put something out there, they've got to worry about, is it going to affect anybody personally? Is there going to be any personal harm involved? What happens if you design a building and it falls down before you even finish putting it up, right? Or it falls down 5 years later, or other tragedies that you can think of, or an airplane doesn't particularly perform well, et cetera, et cetera. So the safety aspects of the final product are critical, and the companies I mentioned worry about that 24/7, and so they make their stuff as bulletproof as they possibly can. The end use company is a perfect example. I mean, they sweat the small stuff because that's what's going to get you in the end, and they have to do it right. And my personal experience is, I haven't sampled all of them, but my personal experience is they have got it right already, and they're getting it more righter, better and better.
Very good. Before we turn to the audience questions, and we will do this in a few minutes, Andrew, do you have anything to add to the same remarks? For example, what is your general observations about the way natural language or AI agents are now implemented in mainstream design and simulation software?
Yeah, I think we saw the first phase of that with the introduction of chatbots and a lot of products taking advantage of the knowledge base of those products or the documentation manual. But I think we found that for the most part, that doesn't meet the expectations of the end user in terms of what they're looking for. And I think what we're seeing with this next wave of agentic systems, it's really trying to solve core problems of engineering and not just aiding with a co-pilot, but really how do we solve some of the challenging, difficult engineering problems? And oftentimes, this is very unique to each company. I always say, if you look at two German automotive OEMs, they both use the same tool stack. They both have engineers that were trained at the same universities, but the product they put out, the process at the end of the day for each one is also very different. And so this is why the need to kind of personalize and customize on a company or group basis how these agentic systems are created and applied is also very important to the future in the engineering space for these systems.
All right, very good. Now let's go ahead and turn to audience questions. Audience, it's your chance to ask questions. Feel free to submit them. We're going to start with some of the questions that we received from the registrants. So let's start with that first. One of the questions is, can AI actually replace all human designers? I think we have actually adequately addressed that. Both of you have addressed that. So I'm going to check that as answered, but let's move on to the next one, which is rather interesting. Will human in the loops always be required for the final decision making, or can AI take over with autonomous decision making? Let me start with you, Andrew. Can AI make decisions that humans will make?
I think AI systems will definitely be making decisions, and as we think about applying them to engineering problems, there's going to be a need for them to be autonomous in some of this decision making. But at the end of the day, there always needs to be a human in the loop here. As engineers, we're designing, as John was saying, buildings or cars or vehicles that interact with humans, and the potential that something goes wrong with these designs could have consequences on somebody's life. And I think with that in mind, when we start to design and create these systems, at least at Sonera, and I'm sure many other companies working on the same problem, they're having an eye towards, we always need a human in the loop. We need an audit trail of understanding what was the decision-making process here, right? Because we don't want a black box. As engineers, as designers, we want to understand how we got to a conclusion so that we can ensure that it's going to meet all of the requirements and not jeopardize anyone's life.
John, what do you think about this? Can AI start making decisions autonomously the way humans will do it?
Not the way humans would do it, but yes, they will make decisions. In fact, they are making decisions and have been making decisions for quite some time. So it's not a novel concept that a machine is making decisions. Now, the real question there is, are the decisions root or are the decisions dynamic and circumstantially based? And that's the dividing line, I think, between what a human does and what a machine does. When something gets ambiguous, the machine fails. It just doesn't know what to do. It doesn't have a big enough data. When something gets ambiguous with a human, an answer is produced. It may not be the right one necessarily, or the most desirable one, but nonetheless, an answer gets produced. And you're going down the road, or something in the middle of the road, and you have to make split decision about, do I drive up on the curb to avoid it, or do I drive into oncoming traffic to avoid it, or do I slam on the brakes and hope I stop in time? An autonomous driving car could not handle that decision. Its default would be shut down, and hopefully it stops in time. And
Right.
just shutting down may not be the best choice. So, the decision-making process will get better and better. It is a function of training. It's a function of eliminating or filtering out the hallucinations that we know that the AIs are capable of. I had a couple of funny experiences the other day. I was doing some research to see some of the numbers of some patents I have, and I suddenly discovered that I had 5 new patents I didn't know about. So, what did this come from? So there's a really blatant piece of hallucination there. But that's being worked on, and the agentic stuff is taking a lot of that out, but it's still there.
There is actually a question from one of the registrants about hallucinations. So let's talk a little bit about that. If large language models, even agentic AI, can hallucinate, how can we trust their results? Andrew, could you give us some insights on, for example, what will AI hallucination look like in a CAD or an FEA program? Have you seen it?
Yeah, I mean, I think hopefully the hallucination actually never makes it to the end user of one of these products, right? That is the goal of all of us as software companies. That, as John was saying, agentic systems now being tied into this process allows you to catch those hallucinations, hopefully before they make it to the end user, that you have something that's validating the outputs before it gets to an end user. So I think, just like John, I experienced, I was trying to do some work with an LS Dyna model, and I was using the documentation manual, and I was saying, hey, give me the right card for this type of battery condition, or tell me all of the cards here. And suddenly it was inventing things that weren't existing there. You go back and you try to reference something, you go, this looks really, really plausible, but it doesn't exist anywhere in the documentation. So I think there's still a ways to go and a lot of different approaches to try to solve that problem. I'm pretty confident that at the end of the day, we won't see a hallucination that designs a plane or a vehicle that isn't drivable or isn't flyable or isn't safe. But certainly there's always going to be need to validate and recheck everything that's produced by these systems.
All right. I'm going to ask John to chime in on hallucination as well. And while John is doing this, Andrew, it'll be great if you start scanning through the audience, the live audience questions, and start identifying a couple of the ones that you'll start to tackle when we come back to you. So, John, about the AI hallucination thing, would it become, so does that mean that the human engineer's new job is now to catch these hallucinations? And how can they do that?
Yeah, that's and to my earlier comments about what's your value add, that's your value add. That is a value add that you could offer. Take an engineer who's been working for, 10 or 20 years as an engineer. He or she is the ideal tester because they know what to do. They know how things work and they know what's been built and what hasn't. And so you can ask the AI to do something and then have a human check it to see if it's legitimate answer. And it doesn't take long to do that. It's, in the simplest terms, that's called due diligence. And one of the criticisms that we find of people who have used AI incorrectly and are accused of plagiarism and other things like that is that they're so damn lazy, they don't even do the due diligence to check what it is they asked the AI to do to see if it did it right. No, I say, okay, you deserve to be destroyed.
Very good point.
Now, the subtext of that is, and if it's subtext, I shouldn't say it, but I'm doing it, is that a day will come, in fact, it's in process, where the AI will check the AI. And we have a lot of models for that. The one I like best is the 3-part model where an AI, let's call him number one, comes up with the answer. And then 2 other AIs check it. And then you vote and see who you agree with. Now, I like that a lot, but it still has a risk that there could be an error that the 2 people who said, yeah, this is right, are wrong. But that comes out of trial and error. I mean, we'll build that as we learn, and that will go back into the database and back into the training and do it. Now, the argument against that is the time. We are so crazy about having everything done instantaneously that there is a tendency to look for a shortcut and take the easier, faster path. The Agentic AI, for example, runs about 2, sometimes 3 times longer than does a conventional LLM. And we're talking about seconds. But if that's annoying to you or you think that that's holding you back, then you're going to go for a quicker answer. And that's where the risk comes in.
Andrew, you have a chance to take a look at some of the live audience questions. Which one would you like to tackle, sir?
Yeah, so I think I saw one from Clement. Let's see. So Clement was asking about, other than Googling AI agent design workflow, what is a good resource for AI agents in engineering? And maybe this is just a self-serving pitch for Synera's next webinar, where we're going to be talking exactly about this topic coming up in June. So Clement, I definitely recommend we have a webinar called Getting Started with Your First AI Agentic Engineer. So tune in for that.
All right, very good. In the meantime, John, also, I hope you have had a chance to just scan through some of the live audience questions. And if you have, I wonder if there is one that you might want to tackle yourself.
I'm not seeing them as well as I should, but oh, there they are. Okay, so I hate to do this in real time. Read it.
Here's one.
Okay, all right. So this is perfect because this is exactly what I wanted to do.
Okay.
So Frank Ding asked, can you give some concrete examples where generative AI is used for CAD or
that's a good one. Very good one.
And for simulation, AI is a real super boom benefit. And you've all seen the pictures of FEA testing where they do it in a computer and a car gets destroyed or whatever it is, or a beam gets bent further than it's supposed to be, and the evidence is proof. We've also seen the pictures where they take a real car and drive it into a wall, right? That's expensive, time-consuming, and dangerous. The AI can do all of that, can do both examples. It can do the nominal FEA test where something is stressed and stretched and stretched until it breaks and monitor it. And it also can do the simulation of a car driving into a wall. Now, in the latter case, the memory load, the processing load, the resources necessary to do that are humongous. And so that's now the current barrier. It's just how much can you afford for your simulation? And so the early tendency of the use of this is It's a divide and conquer type process, which all engineering is. Break it down into smaller parts. And so you don't test the full car. You test maybe a wheel or maybe a drive shaft or a little piece, right? And then you do another piece and another piece, and then you kind of assemble it and so forth until you've reached the budget of your resources that you can't test anymore. And so now it behooves you, okay, if I can only test one thing, what is the most important thing? There's your differentiation. That's what separates you from the AI. You are now making a very important decision that no computer's going to be able to make. And so now that's your value add.
Yeah. Andrew, here's another question from the same person, actually, that might be relevant to you. He wants to know, is workflow automation the same as engineering AI? What do you say to that?
Yeah, I think that's a great question. For me, workflow automation is the precursor to engineering AI. Before you can think about applying AI to many processes today, you need to at least start to automate that and document that process. So what we see with our customers at Sonera is they construct their automated processes using Sonera's visual process builder, and then they start to attach those to agents, right? Because as I said before, the process of a German automotive OEM compared to another German automotive OEM to design their vehicles is different, right? And we're going to want these agentic systems to be customized, to be personalized based on each company. But I think that automated approach is the precursor always to then bringing in agentic AI to solve those problems.
John, since you mentioned AI fact-checking other AI's responses, maybe you want to tackle this question that came from Michael Woodward. A challenge will be that the rate at which AI can generate work, people might not be able to keep up with the fact-checking. Is that a good observation?
Yeah, yes. Yeah, but it's probably the machine will always outrun us. And again, it's the hurry up syndrome. So we want to get results. We want to get to market before our competition does. Variety of other, motivations telling us to do something faster. So if we then become the bottleneck, we're going to get squeezed out. So there's another place where you have to look at what's your value add. Are you really helping the process, or are you holding the process back? And that's going to be a constant challenge. That challenge is never going to go away as long as we are part and parcel of an interface with a machine. As long as the machine's our partner, then we're going to constantly have this battle of master slave, who's driving who, and who's the bottleneck. And the machine almost never be the bottleneck.
Andrew, are there any other questions that you'd like to tackle from the live audience that you can see, or would you like me to pick one for you?
I see a recent one from Michael that I think is a good one to talk about here.
All right. Could you read that and then?
Sure. So Michael asking, as it is today, 3D modeling and FEA have increased the thought burden on engineers, and they have no time to sleep on it because they're doing 20 times the work of an engineer 2 decades ago. And I think that really epitomizes the problem that a lot of engineers are facing today. I mean, especially simulation engineers, I hear the ratio oftentimes they're out between 5 to 1, so 5 designers for every 1 simulation engineer, up to 100 to 1. So you have 1 simulation analyst, 1 simulation engineer responsible for the designs that 100 designers are creating. And this is a real challenge for the simulation team. We often hear that there's a 2, 3, 4 week backlog of designs that need to be analyzed and feedback set to the design team. And I think this is when I was talking early on and introducing some of the challenges that multi-agent systems solve, this is exactly the type of challenge you want to solve with a multi-agent system, because it's a communication breakdown, a lot of these problems. And many times the tasks of a simulation engineer, it's very repetitive. It's analyzing the same parts from one family or slightly reanalyzing a design from before. And I think once an engineer can build up their process in a way that is trusted, then they can allow an agentic system to apply that to designs and free up that engineer's time to maybe focus on validating results and double checking things more than clicking around in Patran to generate a mesh or apply boundary conditions or combing through an Excel file to read in all of this information that's needed to set up the analysis and focus on the real value added part of being an engineer.
All right. John, do you want to add something to what Andrew has just said, or is there a different question you'd rather tackle from the audience list?
I want to ask you a question, and to do that, I need to bring up my opening slide, if I may.
Yeah, go ahead. Go ahead and just select it and
is it shown?
Live. Let me see here.
So what many of you may
Yes.
not know in the audience and the panel is Kenneth Wong is a very accomplished fine artist. And well, he's being modest, but in fact he is. So Kenneth, I want you to look at this picture. Which look at
Yes.
all the stuff that's in it, the lamp in the background, the drawing, the table, the window, the pencils and boxes, the robot
Yes.
itself, and so forth. How long would it take you to create that image?
That is somewhere between 4 to 8 hours.
Yeah,
if I were to do this manually.
Guess how long it took me?
I'm guessing seconds.
30 of them. Yeah. 30 seconds. And it was just, and of that 30 seconds, probably at least 10 of them were used in figuring out how to tell it what I wanted.
Right. Yes.
And just,
so in essence.
And I needed that picture. This picture is another book I wrote, but anyway, so this picture has that double purpose, is that I needed the picture to illustrate a robot doing a task that a human normally would do. In this case, he's doing a CAD drawing. 30 seconds. I couldn't do it in a day. You could do it in a day. You're an artist. It would take me days to try and get that, and it would look like hell. So there's the benefit.
Would suggest to me that we need to be learning how to write proper prompts so that the AI can spit out the kind of 3D models and simulation jobs that we want it to do. Oh, yeah. Andrew, how about you? Is there any other questions in the audience list that you'd like to tackle, or any other things that you want to add on to what you have said before?
Just looking through, I think I saw another one about how are these tools being commercialized, and what does it cost to utilize these programs or agentic systems?
Yeah.
And I think that's a great question. There's a lot of exploration going on in the market today. Engineers are trying out all sorts of different tools. I think a lot of folks maybe have seen products like N8N and others, or John also talking about using image generation tools. And I think the way these are being commercialized is still a process that's evolving. At Sonera, we believe we're bringing out the first agentic builder platform for engineering professionals to really focus on these engineering problems. And of course, the cost to bring those out and utilize agents, well, you're going to need to have licenses for your Anthropic account or your OpenAI account, along with some cloud infrastructure. It's more an exploration, I would say, at this point in time that's required. So bring a willingness to learn and experiment with these systems. And companies like my own Sonera, we're interested in helping you on that journey to bring these systems into your engineering organization.
All right, very good. We're coming down to the last 10 minutes. So let's do this, gentlemen. Let's pick one question each that we'd like to tackle from the audience list. And then after that, I'll give you each a chance to do your closing remarks. And then we'll end the show, okay? So, John, is there a question that you'd like to tackle from the remaining list?
I'm looking at this one question. I'm having a hard time understanding it. Richard Stobe is asking, compare the analysis of a company starting overseas that brings it to the U.S. with a different or similar. I don't know what to make of that question. So, but I'm very curious about it.
Yeah, I'm not sure. It seems like the question was cut off midway or something. But if
Uh,
that's the case, John, do you have any thoughts that you'd like to share,
well,
independent of the audience question?
what I think Richard is asking here is how would the usage of AI compare between, say, Europe and the United States?
Could be.
Because the European Union has a different set of rules for the use of AI, and the United States has its point of view. The European Union is more cautious about safety and about plagiarism, and especially plagiarism. And I think that coming from Europe to the U.S., you might find that the U.S. moves a little bit faster than Europe does because it's not as cautious. And so that could be a handicap for a person coming from Europe to the United States to try and be competitive, is that they have to learn how to, maybe take a couple of shortcuts, run a little bit faster, take some chances, et cetera, that they wouldn't normally do in their home country.
Good point about the comparison between the two different regions. Andrew, do you want to add anything onto it, or would you like to tackle one of the questions?
I mean, I think it's a great topic, especially as a European-based company, a German-based company.
Yes.
We encounter some of these regulatory questions, but I can assure everyone that European companies can move just as fast as American companies on these topics. I think at Scenario, we've been laser focused on this topic and moving very quickly in the agentic space. I think the exciting thing for a lot of us is it's a topic that's moving so fast and so quickly. We see today so much talk about MCP and connecting to different tools and products. And now I think there's 10,000 different MCPs floating around, MCP servers. It's incredible to see how fast things are moving. But John's right. The regulatory environment is different in each country. And this is also why I think we'll see a lot more what I would call federated learning with these agentic systems. So we'll start to see these systems trained not on all of the available information in the world, let's say, but you'll see companies start to build their own agentic systems with all of the information that they have inside their organization. And they'll use those systems to accelerate past their competitors. So if you're an automotive OEM and you've done a great job at data management for the past 20, 30 years, you're going to be able to take advantage of all that data that you have locked away now to help you build the next car in not 5 years or 7 years, but in 3 years. Mm-hmm. And so I think that's really where maybe the regulatory challenges will actually help bring about a better approach for many companies.
All right, very good. Audience, if you have some questions that remain unanswered, we will pack them up and then we'll email them to John and Andrew so they can respond to you separately at their own discretion, of course. So now it's time to do some closing remarks. So let me go ahead and start with you, Andrew. Do you want to give us a roundup, a closing remarks, or do you want to remind people perhaps of some of the upcoming events that might be helpful to them or resources?
Yeah, maybe just a few closing remarks and then a short reminder to our upcoming webinar. But I think the takeaway I have is agentic systems, AI systems are not going to replace designers and engineers that add value to the process, that take advantage of humanity to do their job. I think where you have people that are very, as John said, robotic in their ways, we'll see those jobs fade away. And people that take advantage of AI systems accelerate and explore new domains and solve more interesting and challenging problems. And now I'll give the pitch again. If you're interested in how you can start to build these systems for your own engineering organization, your own design organization, I recommend you join us in just a couple of weeks for our Scenarios webinar, where we'll show you how you can start to construct your first digital engineer using our agentic platform builder.
All right, very good. John, your closing remarks or any last minute thoughts you want to leave behind?
Yeah, a couple of them. Number one is, the expression to the guy that has a hammer, every problem looks like a nail. AI is not going to be a panacea. It's going to do a lot of stuff amazingly well, but it's not the only tool in the toolbox. And we shouldn't get ourselves too carried away with what AI can do, but look at it as being one of our very useful tools. On the personal side, I want to tell you about experience. We spent the last 2 years and more money than I wanted to developing what's called a RAG, which is a LLM based on your personal data, not my personal, but your organization's data. And we've got data going back 40 years. And it's been an extraordinary experience. The other day, I did a report that required me to dig into 3 different databases in order to get the results I wanted to make the conclusion that I was trying to get to. The LLM, and that took me a day and a half. The LLM did it in 20 minutes. And it turned out to be a test case for us to see how well our RAG LLM was working. And that's an example of the time I could have saved if I just gone in first and had confidence that the system was working. So it's going to be an incredible productivity enhancer. And if you use a RAG, you avoid a lot of hallucinations. In fact, you probably avoid all of them because it's your data. And it's kind of hard to make that up. And you know it because it's your data.
All right, very good point. Gentlemen, thank you very much for sharing your thoughts and engaging with me in this discussion. In fact, this live discussion was made possible by Sonara, so we'd like to thank Sonara for making this live discussion possible. We'd like to thank you, audience, for spending your precious afternoon or evening or dinner time or morning, whatever that may be, with us. I really appreciate it. You also get a little prompt to fill out a survey. It's really helpful if you can fill out and tell us what you think about this webinar and what other topics that would interest you, so that you'd be willing to tune in, and we will see one another again. And for the time being, I also want to thank our webcast producer, Steve Paul, who worked behind the scene to make us all look good and sound good and everything goes smoothly. And I'm Kenneth Wong. I'm Senior Editor for DE24/7. And ladies and gentlemen, until next episode, we're out.
Bye-bye.
So